All right, today's notes on recursive equation and annotation, okay? So it's going to be pretty similar to what we've done before, okay? So let's go ahead and do an example one real fast, okay? And we'll start off with a sequence, 7, 12, 17, 23, dot, 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 okay? Now, just by looking at this, we should know that the this is going to be an arithmetic sequence, and it's going up by 5. Yes or no, guys? Right? Okay. All right. So we know it's going up by 5. That is called a common difference. Okay. So the common difference is called D is equal to 5. Oops. This one is supposed to be a 2. My bad, guys. Let's put a 2 here. Sorry for that one. All right. It's going up by 5. Okay. So now we know how to write our equation. We know how to find the number before. In fact, for a sequence, it is actually not important to find a number before. Okay, because there's no actual number before. Because the sequence always starts with 7. The reason why we want to get used to find a number before is just because of linear equations and stuff like that. They always need the number before. Because what's the number before?
2.
2. Okay. All right, then we write our equation, and it happens to be T of n is equal to, again, this is an arithmetic sequence, so we write down your common difference first, which is 5, and then we start with 2, okay? Now, we'll do a recursive in a second, okay? But there's actually another way to write an explicit equation. The reason, here's another way of doing it, is because, again, sequence, there is no such thing as a zeroth term. So without the zeroth term, how do you write that without the 2? Okay, so let me show you guys quickly. So there's another way of writing it. Okay, and this is a annotation way. Okay, so then you just write down, well, because it's, again, if the 2 doesn't exist, you start off at 7. Okay, so therefore you need that 7 first. Okay, so you write something like, they usually like to write down, anyway, we'll write like this. So 5, okay, my n minus 1, all right, and then that would be a plus 7. Okay, so that's another way of writing it without the zeroth term. Okay, you can check your answer. You put a 1 right here. 1 minus 1 is 0. Okay, so that would be your, watch, let me think. So yeah, 1 minus 1 is 0. Okay, and then 0 times 5 is 0, and then that gives you 7 the first time. Do you guys know what I'm saying, yes or no?
Yes.
Okay, good. All right, now how do you write the recursive? So let's go ahead and bubble this in real fast. So how do you write the recursive? Okay, so for your recursive, okay, they always want you to start off with your first term. Okay, so we already know what the first term is. The first term is equal to 7. Okay, now since it's equal to 7. Then therefore, so recursive, they already give you the first term, okay, and then therefore they want you to be able to see what the second term is, okay. So you rewrite it like this, guys. It's a little bit tricky, okay. So then this will tell you that the second term. So again, if you write down what the first term is, so let's say the first term is 1, so that will give you 1 plus 1, which is 2. That will be the second term, okay. And you can see that it's just going up by 5, so it's add 5. So then the first term, add 5. So the first term plus 5. And that is your recursive equation. Okay, so that one is a little bit tricky again. So again, this is T right here. Okay, so again, whatever your first term is, which is 7. Okay, so let me just show you guys quickly again. Okay. You're good. Okay, so again, if you put a 1 here, okay, so let's put a 1 here. We did this last class, so 1 plus 1. Okay, so that will give you T of 2. Okay, and if you put a 1 right here, plus 5, and then you should know what your first term is. It tells you that your first term is 7. So you replace this with 7 plus 5, and that's how you get 12 as your second term. Okay, that's how you get 12 as your second term. Do you guys know what I'm saying, kind of? So your second term is 12. You see that? So this is your recursive equation. All right? It's always going to be the same for the first part. So it'll be n plus 1 always. Okay, and then whatever your first one is, okay, and this one is common difference, so you add 5. All right, and we can do one more practice later on. Okay, draw your line. Let's go ahead and do one that is a geometric one. Okay, so example 2. All right, so we start with 6, 18, 54, 162, ... All right, this one here looks like it's not a arithmetic sequence. It's going to be a geometric sequence. Yes or no, guys?
Yes.
Okay. What's the, they call it the multiplier, okay, or the common ratio, same thing, and they use the letter R. All right, guys? So it's multiplied by what?
3.
3. Yes or no?
Yes.
Okay. So our equation before was, oh, okay, let's go ahead and find out the number before. All right, guys? So what's the number before 6? 2. Can you divide by 2? Now, in sequences, there is no 0th term. There's no such thing. Okay? So we write our equation with the 0th term. Okay? So T of n. Okay? Or A and or B, you guys remember that? So you start off with the 2 times the multiplier, which is 3. I'm going to use a parenthesis to the nth power. Okay? That's what we learned before. Now, to do an annotation, you have to do it without the 2. Okay? So to do it without the 2, all right? So it's the same thing. Okay? All right? So to do it without the 2, you just have to write down not the 2 itself, because there's no 2. You have to write down the 6. So this is your first one. So 6. Okay? And then your multiplier is the same, but for the n, you write down n minus 1. All right, so this is an annotation way. Okay, so again, because there is no 2. Okay, so you take the first one. Okay, and then it's the same as the multiplier, but you put n minus 1. And we could check our answer real fast. Okay, so the third term, let's just do the third term real fast. So 3. 3 minus 2. Okay, it's 2. 3 to the second power is 9. 9 times 6 is 54. So it still works. Okay, except that this one here doesn't have the 0th term. All right, so this is going to be your explicit equation. This is the annotation. This is the regular explicit equation. Now let's go ahead and do the recursive. Okay, so the recursive will be the same. All right, so get T, and it was always going to be n. Oh, they want you to list the first term first, so let's go and do that. Okay, so the first term is equal to, again, ignore the 2. The first term is what, guys? 6. Okay, and then your equation itself. So you have to list this one. This is part of your equation. So you have to let people know that this is your first term, and then to get your second term, okay, it's going to be same thing, guys. N plus 1. So that doesn't change. Okay. Now earlier it was adding 5. See, that's how we have add 5, but this one has multiply 5. So then you just, all you have to do is just write down T of n times 3. That's it. So earlier we had a plus 5 because it's a arithmetic sequence, you add 5. But this one is a geometric sequence, so it's multiplied by 3. So it's multiplied by 3. And then that's your recursive equation. Okay, so it's the same thing. You list the first one, you write down n plus 1, and then you just T of n times 3. Okay, so if whatever your first term is, which is 6, okay, so that 6 times 3 will give you 18. Okay, and that's how it works. All right? All right.